Greetings, Chem 2 students. Mr. Keister here with you again today. This is the video for Tuesday, December 1st. My goodness, it's December already. 2020, which is our scheduled 70th day of school for the fall semester. Man, we're in December, folks. That means the end of the semester and finals and all that good stuff, and Christmas and all the other great holiday traditions that all of you enjoy so much, as well, of course, as our winter break, are all on the very near horizon. So, we're in the home stretch now, so let's stay buckled down and get through it and do everything we need to do, shall we? All right, well, let's take a look then at, well, I've got to give you my spiel first, always keep in mind that the dates could change for a variety of reasons, but the lessons and the order that the lessons are presented will remain the same regardless. Can't forget that disclaimer. Not this year, anyway. Okay, so now let's take a look at the do-nows and see what our schedule is for today. So today we're going to do Lab 6.1 over percent composition empirical formula, which is page 91. You're also going to pick up the Unit 6.1 exam review, page 92, as we have a test coming this coming Thursday. I'll mention that here again in a minute. We didn't pick up anything yesterday. Actually, we completed an assignment that we began before the Thanksgiving break. And so that homework was the percent composition, empirical formula, and molecular formula assignment. That is now due, and I am collecting it. So if you're here in class, that should already be on my desk. If you are at home, then that needs to be submitted to me electronically during your regularly scheduled class time. So do not be late. All right. Of course, you can check your answers here at school on the board or at home on the answer keys page in Canvas before submitting to me. So today we're going to shortly head back to the lab and do Lab 6.1 over percent composition empirical formula. The calculations will be just like what we did for our homework in regards to those two topics that was due today. That lab is due tomorrow at the beginning of class, and of course I'll be collecting that too, as I collect all labs. You all know that. Unit 6.1 exam will be this coming Thursday, day after tomorrow. The study list I'll post in Canvas later today, and I'll put it up on the front board tomorrow. And so tomorrow during class, we're going to have a work day so that we'll go over what you need to know for this exam, and also then to have time to complete your Unit 6.1 review assignment and get it checked, hopefully before you get out of here tomorrow, so that you have it with you to study with. All right, so with that being said, let's head back to the lab and do Lab 6.1. So let me unplug here, and we'll head back this way. I'm trying to see back there if I got a pair of goggles out. I don't see any. So swing by here first. Grab a pair of goggles. There we go. Yeah. All right. Once we get done doing the procedure, we'll head back to the front. We'll talk about the calculations a bit. All right, so let's see. Let me set this right here. And again, well, you know what? If I can put that up on something to make it taller so you can see better. So let me set this down just a second. Let me grab a box over here. There we go. These things come in handy. Put this up here like so. And oh yes, much better. Much better. All right, let me swing back around. And again, this is gonna cut my head off. For some of this, I'll try and lean over so you can at least see me, and then we'll get the procedure started here. So I have the lab paper in front of me, so I have this in front of you. I'm looking at the first page. under the pre-lab discussion. So percent comp or mass percent of a compound is a percentage by mass of each element that goes into forming that compound. Of course, we talked about this in the last several days. The empirical formula of a compound is the simplest whole number ratio. Remember, elements combined in whole number ratios to form compounds. That came straight from Dalton's theory. According to the law of definite proportions, which is part of Dalton's theory, which we just talked about. So in today's lab, we're going to experimentally determine both the percent composition and the empirical formula of magnesium oxide. Now, I realized that you should all know the actual formula, the true molecular formula for magnesium oxide, which is an ionic compound formed from magnesium and oxygen. Shouldn't take you too awfully long to figure out that should be MgO, since Mg forms a +2 charge and O forms a -2 charge, so they combine in a 1-to-1 ratio. We'll see how close we get to that. Okay. So today's lab will also make use of the conservation of mass. We're going to be using masses today, which states that the total mass of the reactants and the total mass of the products must remain the same. So if we start with a given amount of magnesium, which I have a piece right here, and we then determine the mass of the magnesium oxide that's produced, then we can calculate by subtraction the amount of oxygen that was used from the air. All right. So now I go down to the bottom of the page, look at the procedure. So we have a piece of magnesium here, metal ribbon from the teacher. I'm going to bend it and make it a more compact piece, like so. Kind of fold it back and forth here. So now you can see that I've made it into a nice little compact piece. And so now I'm going to weigh it. So over on the next page, we have our data table. So let me put that on let me balance that out there, zero it out, put that on there. And we are at, flipping back and forth a little bit there, 0.25 grams. So in the data table in the first line, the mass of the magnesium ribbon is 0.25 grams. All right. It also asks us to find the mass of an empty crucible and lid before heating. So I will do that next. So here's our crucible and lid. That on there. And that is 29.27 grams. 29.27 grams. All right. So we're going to put this on the clay triangle, which is, of course, to hold that crucible. And I'm going to put the piece of magnesium in there. I get the old goggles on now. Here we go. All right. And so fire this thing up. There we go. And that looks like a nice cone there. I think we're good on that. And so it says to place the magnesium in the crucible, to place the crucible in the clay triangle. We've done that. Put the lid on the crucible, leaving a slight opening for air to get in. Okay, so if I put this lid on here like that, then once the air is used up inside, the reaction is going to stop. So we want to make sure it gets enough oxygen in there. So I'm just going to kind of put it like so, which leaves it mostly covered, which will allow for it to heat faster, of course, but at the same time allow it the oxygen it needs for the reaction to go to completion. So I'm going to put this under here. And let's see, that looks about right. Right at the tip of the cone there. And now we'll wait. All right. So when the magnesium, I'll go ahead and put this up for a second. So there we go. As the magnesium gets hot enough and combusts, it combines with the oxygen. It's got to be at a certain temperature in order to react chemically. And so we are waiting on that to happen. I'm kind of peeking in there. And it's going to start to glow. As you can see, the crucible is getting very hot. Let me go cut one of the lights off a little bit. You can see better. There we go. Maybe not so much glare now. And let's kind of wait till that gets a little warmer. And then I'm going to take the lid off as according to the instructions. All right. It's not ignited yet, so we'll wait a little longer here. Definitely getting hot though. Ooh, I think we're getting close. I'm going to try and be very careful doing this here because I want you to be able to see this as I pull this lid off of here. Hopefully I'm not too clumsy trying to do this left-handed. And let's see here what we got. Oh, it is getting ready right now. So let's take a look there. Can you see down there? All right. And we can see that thing igniting now. So what's going on now is that magnesium has ignited and is now forming magnesium oxide. So let me grab a spatula here. And kind of stir that up a bit. Oh, see that? There we go. Now, as I do that, I'm getting some little sparkling. I don't know if you guys know this, or remember this, but sparklers that you get on the 4th of July or other holidays, as you can see there, are made from magnesium metal. And they sparkle a very bright white, of course, which is kind of what I'm looking at right now. I'm going to let it continue to heat until I don't see any more sparkling, any more reacting. Hopefully I don't spill too much of that powder there. So the residue that's left now is a grayish, powderish looking stuff. And that, of course, is not magnesium metal anymore, but that is now the compound magnesium oxide. And it looks to me, I don't see any more reacting going on. And so I'm going to kind of tap that off. I don't want to have too much of an error there. Set that there. And turn the heat off. And I'm going to set this like I did the crucible lid. I'm going to set this on the clay triangle to cool. Because they don't want to put that thing directly on the balance with it being this hot. So I'm going to kind of bring this over closer to the camera there. And if you can see inside there, it's a grayish, a very light gray, whitish colored powder. That, of course, is, like I said, not magnesium anymore, but now the compound magnesium oxide. So what we did then is we took magnesium metal, it reacted with the oxygen in the air, to produce this compound magnesium oxide. So I'm going to take these off, I think. I'm going to let it cool for a little bit, and then we'll set this on the crucible, or I should say, set the crucible and the lid and the magnesium oxide on the balance and find its mass. Since we have the mass of the crucible and the lid empty prior to doing this, then we can find the mass of the magnesium oxide simply by subtraction. And we will do that here shortly. I'm going to let that cool just for a little while longer. And then we'll go ahead and weigh it. All right. I'm going to set this over here on the balance. Put the lid over there too. Put it back on like we did originally. Notice I'm not touching that thing. That thing's still hot. 29.68 grams. 29.68 grams. So that goes in the third blank of our data table. So I think I'm going to head back up to the front and I'll get you started on this data and calculations, and then I'll turn you loose to let you finish up. So let me get this thing here, and we'll head back up to the front. Get plugged back in here. There we go. Let's set it back up. That looks about right. And let's pull up the lab paper. On the second page, I should say the back of the front page here. And there's our data type. Okay, so just to reiterate what we have so far. So the mass of our magnesium metal ribbon that we started with was 0.25 grams. And the mass of the empty crucible and lid was 29.27 grams. And the mass that we just weighed of our crucible lid magnesium oxide product was 29.68 grams. So the mass of the magnesium oxide alone would then just be the difference between these last two pieces of data. Let me turn the light back on. It looks a little dark in here now. Here we go. Sorry about that. And so 29.68 minus 29.27, 0.41 grams. 2 decimal places. Remember, we're keeping our precision level the same. Okay, so now, under calculations and evaluation. So based on the conservation of mass, what mass of oxygen then was used during the reaction to produce the magnesium oxide? Well, so remember, if we have the mass of the magnesium and the mass of the oxygen that we use, that would then give us the mass of the magnesium oxide. All right. Like I said, we know its formula already from, that's what we studied here in this last month or two. But we're going to determine experimentally how close we get to that. And so if we started with 0.25 grams of Mg and we ended up with 0.41 grams of MgO, then how much oxygen did we use? Well, subtract 0.25 from 0.41 and we get 0.16 grams then of oxygen. Okay? So now in calculation 2, you're asked to calculate the percent composition of magnesium oxide based on the masses of magnesium, oxygen, and magnesium oxide determined above. Okay, so remember percent comp, Mg and O. All right, so our masses we have are 0.25 and 0.16. And remember, when you calculate percent comp, if you have a formula, which we technically do, but we haven't determined it experimentally yet, we can just use its molar mass from its formula to do percent comp. But we're going to use the masses we actually used on our data table. And so 0.25 over the total, 0.41 times 100, and 0.16 over the total, 0.41 times 100. And that will then give us our percentage of magnesium and our percentage of oxygen, which I will let you guys do on your own. Remember, for percent comp, to take them out 2 decimal places. All right? And then, based on your percentages in number 2, determine the empirical formula. All right? So here again, we're going to use this percentage right here, whatever it is, and divide that by magnesium's molar mass. Remember how to do empirical formula, which is 24. And you get so many moles. All right. And then we'll do the same thing. Take our oxygen percentage. We go up here over oxygen's molar mass, which is 16. And you get so many moles there. Remember then, once we do that, the second step is to divide both of those by the smallest number of moles. One of these, of course, will be 1. The other, well, now that's going to depend. So If it's a whole number or very close to a whole number, like, 0.1 or closer, then we can leave those alone. If one of those is not close enough, then of course, remember, we have to multiply both of these by an integer, the smallest whole integer we can get, so that would turn that decimal number into a whole number. If you've forgotten how to do that, just look back at the notes. We did this in the notes just a couple of days ago. All right. Then on the next, so I'll let you finish that. And then on the next page, and we discussed this earlier, as you should already know, the correct formula for magnesium oxide is MgO. All right. Based on this formula, determine the correct percent composition. All right, so we have Mg and O. Okay, so you would need to find the molar mass of MgO, which is pretty simple. All right, and then that number, molar mass, goes down below, and magnesium's molar mass goes up top here. O's molar mass goes up top here, and then of course times 100. And that would then give you the percent composition of each of those, all right, based on its true formula. And then in number 5, you're going to use your experimental calculation of the percent comp from number 3. Determine your percent error for the percentage of magnesium in MgO. So from number 3 would be your actual percentage, your lab result. The correct percentage, which of course is the theoretical percentage, comes from up here, all right, like we did right here. And see how close you got, all right. It's pretty close, actually, all right. And then list 2 specific reasons why our percentage isn't exactly as it should be, all right. Well, think about the procedure we did back there, and I'll bet you can think of a couple of things that could have led us to some type of an error. All right, I'm going to let you do that on your own. So I think that's it for now. So again, this is Lab 6-1. This is due tomorrow at the beginning of class. You'll be turning it in first thing tomorrow as class begins. All right. Tomorrow again then is a work day for Unit 6-1 review. We'll talk about the test, what you need to know for that, and then Thursday will be exam 6-1. So I think that's it for now. So until next time, this is Mr. Keister signing off. Take care, everyone. Stay safe, stay focused, and keep working hard, okay? See you next time.